So when SAP is saying so many things about HANA, we just need to understand how they are going to be helpful at your application programming level. Finally, we just need to improve the program performance, save the program time, internally save the end user time and their money. That's what our intention. So let us try to understand what is happening in the traditional approach, how the HANA can replace the traditional approach with a better approach. That's what we are going to discuss. So yes, please. Yeah, this is what agenda we are going to cover today. So what exactly HANA for? And HANA, most of the people will know that HANA is a database. Yes, it is not only the database. It is not only the database. HANA can be used as an application. We'll see one by one. Don't worry. And HANA as an appliance. Okay. So, and this is all about HANA and its architecture and its technology level. Programmer level, this one. Programmer level. This is a new approach. So at the programmer level, this is what we are actually talking about HANA ABAP. So what if HANA is your backend or application? What are all the changes we are going to do in your ABAP program to get the maximum benefits from the HANA? That's what. So this is not differently a separate ABAP kind of thing. It's just earlier we work with many databases. Now we are going to work with SAP's database. But these databases are a bit different from the technical databases or traditional databases. That differences we need to understand today. Yeah, these are all technology level. This is all programming level. That's what we are going to discuss, these two things in detail. So is that clear? Is everyone is able to hear me? I should ask them in the initial day. Yes. Yes, thank you. Yes. Yeah. So we can proceed, right? Yeah. Yeah. This is what HANA stands for. Just Suresh, do you have any question? It seems your hand raised. Just Suresh? N. Okay, I'm just muting you. Yeah. So let us try to understand these things one by one. Yeah. So that's what, as I said, no, it's in single line in one point. We just need to understand what is HANA, and this is what our intention as a programmer, as an ABAPer. As an ABAPer, our intention of this course is, okay. So the course is how to get benefited from HANA features from the ABAP environment, from the ABAP programs, but we can do it once to understand the HANA features. We'll see that one by one. This is what HANA stands for: high performance, analytical, and appliance. So HANA stands for this one: high performance, analytical, and appliance. In a single line, what I wanted to say, appliance is both hardware and software combination. Hardware and software. It's very simple. When you wanted to check your laptop performance or your mobile performance, when you check your mobile performance, first question is, so what is the memory, what is the processor? Yeah, if you really have any question, you can very well raise your hand so that I can unmute you guys so that you can talk to me. No issue. Yes, usual. If If you feel like asking some question, if it really helps, so definitely you can raise your hand. There is a hand raise icon. Just raise your hand so that I can unmute here, and then we can have the discussion. Yes, it's for everyone. Yeah. So when you say appliance, appliance is not only just software, even it is hardware. Because very common question is, when you talk about your mobile performance, the first question is what is the processor you are using and what is the operating system. Is it Android or iPhone, so and so. And then what type of OS, again which version it is. This is about software. And next one is your RAM, your processor, your memory, in memory, built-in memory. These are all comes into picture, so that the performance is not only linked to the software, even to the hardware. That's what SAP is saying. And HANA stands for high performance analytical and appliance, means it is an appliance. It's a combination of hardware and software. For what? For analyzing your data. That means your reporting mainly, because and reporting is the main place where the managers will use it, where the decision making will takes place, where majority of the top level people depends on the reports. If that is not done now as effectively as possible, the entire management is in trouble. So that HANA is an appliance, means both hardware and software combination. For what? For your analytical applications. But with what? With high performance. This is what the target of SAP. This is what target of SAP is, to deliver a product which is the combination of hardware and software for analyzing your application data with high performance. This is the goal of SAP. Even they name the product, or they provide something like this. It is not only just the name of the product, even it is the aim of the product, aim of the product, aim of the SAP. So now we'll see one by one how it is really helpful to improve the performance, and then while analyzing the application, so how this appliance, I think it must be clear, because nowadays not only the software, even hardware matters. Because if your system is not working or not performing good, we try to just increase the RAM, upgrade the RAM, isn't it? So hardware has that much importance nowadays. Okay, so that is the reason. Yes, I want everyone to understand, it is just not the product name. It is aim of SAP. What? To deliver a product which is the combination of hardware and software. For what? For analyzing your applications with what? With high performance. So just as a single line, we read like this: high performance analytical and applications. So now we need to understand how HANA is really going to helpful to increase the performance of your product. How this hardware and software is also helpful. Software means your database, you can say. Hardware is this kind of RAMs, hard disk, processors, these kind of things. We'll see how SAP is taking the help of both these things to optimize the performance. Now, before getting into these things, we need to understand the traditional approach. Because when you want to say this is good, we have to say something is bad, right? That something is your traditional databases, and the other one is HANA. When I wanted to say HANA is good, I have to find out some drawbacks from the traditional databases, how they are actually working. So how HANA is going to overcome that. So that is the reason. So we just need to understand the actual process in the organizations, what is the current approach they are doing, and how HANA can and replace those limitations, etc. So for that, so this is a basic discussion. I wanted to discuss something like OLTP and OLAP. So generally, we ABAPers know that we are working with OLTP, Online Transaction Processing System. Any applications in an organization in general, because when HANA is for analytical, we need to understand what is analytical and what is the other one. So basically applications are classified as OLTP, Online Transaction Processing. That means your daily transactions like your sales, purchasing, production, all these things. For that, there are some dedicated systems. We call it as OLTP, Online Transactional Processing. For example, in SAP, the SAP ERP, whatever the ECC we are talking about. So this is what SAP ERP, in which we have many modules, like MM, SD, PP, HR, etc. Yes. Now this is what we know, that majority of the times we work on this system as an ABAPer. Now this is for the daily transaction where the lakhs of millions of records will be keep on added, customer sales, purchasing, their invoices, billing, all these things. Then I need to develop a report on the last 2 years sales. I just need to develop the report for the comparison on the last 2 years sales. Assume that it is something like your central or big bazaar, etc. For one day, in one day they have lakhs of transactions. Like that in a month, like that in a year, like that so and so. 2 years data if you are processing on this system only, which is working on the daily basis, and this system performance will be degraded. If this is degraded, there are thousands of users are working on the system daily. So what SAP, not only SAP, in general, it is not recommended to load the system just for your reporting purpose, especially when you want a large amount of data, not only today data, yesterday data, when you want the chronological data. So like 1 year, 2 years, last 5 years data, that time it's not a good practice to overload the OLTP. Then the other types of systems came into picture called OLAP, which is exclusively for analytical processing. So here we have some tools, exclusively some tools. If you talk about SAP, the tool is BI, reporting tool. In this reporting tool, with the minimum effort, we can develop the reports. Yes, but this tool cannot understand your raw data. The tool can understand some prepared data. If it is BW, we say info cubes and all. So now, but still your actual data remains in the OLTP, no? So what we need to do, we need to transfer the amount of data, not all the data, whatever the data you wanted to analyze from here to here. This is technically we call it as data provisioning. For data provisioning, there are some techniques again. So once the data is replicated here, then on the top of this, some data will be modeled. That is what generally BW terminology is, modeling and reporting. They worry about modeling and reporting. What is this modeling? Your sales data is there in 10 tables here. The sales data is there in 10 tables, but the reporting tool cannot understand the 10 tables. So all the 10 tables data we need to model in a place called something like InfoCube. That InfoCube's information this tool can understand. So a simplified format. So that and all, of course, not our job. But what my intention is, so the OLEP came into picture mainly not to overload the OLTP. Let this is used by the users of every department. This is used by the management of each department. So that when you are developing a report, this is not going to be overloaded because the data is going to be replicated from here to here. This is what happens very commonly. This is what happens very commonly in every organization. But what I want you to understand is OLEP as a separate tool or application or system came into picture only for one point, not to overload the OLTP. If you can avoid that overload in the OLTP, if you can do the things faster in this OLTP itself, even this is faster application. This is better. I repeat, even developing the reports on this OLTP directly is better because you are doing something on the place where the data actually resides. Instead of getting a copy of data from here to here, the replication may be daily, weekly, monthly, and maintaining two different systems. So this is what happens in the traditional database. What SAP HANA says, yes, I can and really handle both OLTP and OLAP in the same machine and without the performance issues. So now HANA is a solution. We'll see how it is. HANA is a solution where you can run your OLTP and OLAP applications together on the same place. So that what you can avoid, the data provisioning part you can avoid mainly. Then when the data provisioning is avoided, a lot of difficulties avoided maintaining two systems and monitoring the two systems and transferring the data from here to here. So that and all happens. Just because of the performance degrade only, we are thinking about another application called OLAP. Yes, I need OLAP, I need reporting tool, but not as a separate system. Why can't you make it part of here only? I need the tool, I need the reporting tool. I want this preparation modeling, but not separately. Why can't in the place where my data actually resides? Yes, that is the first aim of SAP HANA. We'll see how they really achieve it. So HANA can guarantee that your OLAP and OLTP can run from the same place. We'll see that. I'll give more information later, but I want everyone to understand first why OLAP came into picture. Because being an ABAPer, generally we are not into the OLAP activities, so we are into OLTP activities. If you are having some BW background, maybe that is different, but ideally, so we don't get into OLAP activities. Yes, Vishal, do you have any question? You raise your hand. Yeah, fine. Is this clear, the discussion? Yes, please. Any questions on the OLTP and OLAP? Fine, thank you. So now, yeah. So now what SAP is saying, yes, I have a dedicated application called OLAP, fine, nothing wrong. I'm happy with the separate OLAP application. But still, even though we have the dedicated application called OLAP, when the amount of data to be analyzed is more and more, then here also that performance issue comes into picture. Definitely the way you handle 10 people and the way you handle 100 people and then the way you handle 1000 people, so definitely this 10 people you can handle effectively, 100 people bit effectively, but when it comes to 1000 and 10,000, and the performance really and matters. So same thing here, when the number of records are billions of millions of records, still there is a question of improving the performance even while analyzing the huge amount of data, that too which is complex. That time when you're still looking for improving the performance of OLAP applications, yes, then yes, there are some places where you take 30 minutes, 40 minutes also just to get the output of it. Then being a developer, whenever you say improve the performance, we have two things. Uh, Being an ABAPer, we say opt for buffering, because reporting and OLAP talk about reporting. When I say reporting, fetching the data. When I say fetching the data, two things will be helpful mainly. So buffering will be helpful, indexing, your second index, primary index, all will be helpful. So if at all you wanted to do something from your end as a programmer, we try to do this kind of things. But still, if the performance is not improved, if the performance is just marginally improved, then yes, now I just want to repeat the story. OLTP, and for analyzing purpose OLAP, not to overload this, OLTP, but still there are some cases where you need some improvement in the OLAP applications, and then as a programmer we try with this kind of things, indexing, buffering, and so and so, and still if the performance is not marginally improved or just improved, not as per the expectations, then we need to just understand what is happening, not only at the program level, at the entire process level. Is anything wrong with the whole process? Because programming level we did everything, still the performance is not improved as expected. Then let us try to understand what's happening in the traditional approach. Is there anything wrong, or is there anything where we can improve even at the process level, not only just program level? So that we are going to analyze now. Yeah, so I'm just going to explain the process here. First, my report needs data from database means we know that it's from tables. Yes, but internally the data resides in the hard disk, right? whatever the database it is, Oracle or so and so, internally your data is stored in the hard disk. One reason is hard disk can accommodate more data because we got hard disk with enough capacity. Second one is it is cheaper. When is it cheaper compared to RAM? I'll come to the RAM now. Okay. Now yes, when you say reading the data from the tables means internally reading the data from the hard database. Database means our hard disk. Then this is what our requirement. User wanted to see some data. We try to fetch the data from the tables. It internally from hard disk. Hard disk is nothing but your database. Now I'm getting into much technical. So we get the data from database table into internal table, right? Then we process it. Okay. So when you are getting the data from database table into internal table, just you remember database table, internal table. Internal table is memory. So that's what your application server, nothing but your RAM memory. So this is the first step, getting the data from hard disk into RAM. Now I wanted to process it. I want to process it. Yes, from your internal table you process it. Okay. Now my question is, any idea why we need to get the data from database into internal table and do all the manipulations on the internal table? Yes, my question is why actually we need to get into internal table, then process the data from internal table. Let us say I wanted to know the maximum sales order value. When is the maximum sales order value, what we generate in a particular sales organization? Generally what we do, we select the data from database table into internal table. In the internal table, we try to sort the internal table, maybe descending by the order value, we get the first record. I think that's what we usually do. Yes, now my question is why we generally don't do it on the database directly instead of your internal table? To avoid the system load and improve the performance. But how the performance is really improved? Just by doing at the internal table than database level? Yeah, it's true. To avoid the performance issues and to improve the performance. But how doing the things at the internal table will really improve the performance? This how it really affects and improve the performance. Yeah, buffering and all over, buffering and all over. Next. Yes, buffering, yes. But my question is, doing the operations at the hard disk is faster or doing the operation at the RAM is faster? At least now tell me. RAM? Yes, yes, thank you. RAM only. But why? Why from RAM it is faster? Don't feel bad because this is being an ABAPer. To understand HANA, we need to understand both hardware and software. Loaded when the system starts? No. Okay, iteration hitting a hard side, hard disk side is getting limited. Yes, next. Why reading the data from RAM is faster than hard disk? Anyone else? Because RAM interacts with CPU. It creates temporary memory, not permanent. Next. No, still I'm looking for the exact answer. So why the things in the RAM is faster than hard disk? So surprising. RAM is in memory. No, next. We have L1, L2 cache which interact CPU directly. Volatile memory is not a good point about RAM. It's a bad point about RAM when it's a volatile memory. And we're looking for the good points. Why the things at the RAM is faster when you compared with hard disk? Dynamic storage. Mhm. Next. Yeah, please text. Please text if you know the answer. RAM can read faster, but why? Yes, yeah, RAM can read fast, but how? Why hard disk? Why not in the hard disk? CPU first goes to RAM. Next. Yeah, you're closer. Which directly interacts with the front-end user. Okay, fine. Almost you are closer. Hard disk is having huge amount of data. Yes, almost closer. But main point is reading the data from hard disk is sequential. See this spindle? It will just keep on rotate to find out the record exactly where it is. Then reading the data from RAM is random access, direct access. Directly it will go to the place where your record is available. Yes, that's what. Yes, Srinivas. Hard disk store is sequential. Yes, in hard disk data is stored sequentially, and then while reading also, just even by seeing the spindle, it gives an impression that it is just keep on rotate until you get the actual information. The main difference between the hard disk and the RAM is the data reading and storing from the hard disk is sequential, whereas from the RAM is direct access. Directly you can go to the place, so that's how the algorithms are built. So that directly, generally what we do, we get the required amount of data, whatever you wanted to process it, we get from a hard disk to the RAM. That means from database table to internal table. Then we process from the internal table. Why we process from the internal table? We know that this is faster. So that definitely when I want the maximum sales order value, I can very well write like this here. Select, I can very well use the aggregate function max. I can say max some sales order net price, NETWR, NETPR, etc., where sales organization equal to so and so sales organization. This is what doing at the database level means. Directly at the hard disk level. It has to travel each and every line. Now here, when it comes to the RAM, it is direct access. How it is? Because it's all how the RAMs are designed. Now that's what I wanted to understand. Instead of doing like this, what we do, we get into internal table, then we process the data from the internal table. Yes, and this is direct access. Yes, exactly. Is this point clear? Now I want everyone to understand this point, main point, because this is about where HANA comes into picture. Yes, thank you. Now, yes. So now, once you get the data into your faster device, I wanted to call it as to make it simple. This is a slow device. This is a faster device. Once you get the data into the faster device, then you do all your calculation. Then the calculated data will be sent to your CPU cache memory, which is much faster. Then produce the results. This is what the entire story. Now, what I want you to understand, from here to here, there is not much scope to improve the performance, because we are already on the faster device. Maybe program level you can do some improvements. While doing the calculations, do it better way than to the very fast device. From that you produce the results. If at all you are thinking to improve the performance, maybe this is the area. Let me discard these changes. Yes. Yeah. If at all you wanted to improve the performance, this is the area that makes sense. Yes. If at all you are thinking to improve the performance, this is the area actually comes into picture. This area, ideally at program level we can do some things, but hardware level and the process level, there is not much scope to improve the performance. This is the area where large amount of time you spend here. When there are 10,000 records, reading all the 10,000 records from the slower device and to get into load into faster device, this is the area. Okay. Now, one question. So now we know that if the data is in the RAM, okay, if you are processing your operations from the RAM, it is faster. Now my question is, instead of keeping the data here in the hard disk, when the RAM is faster, Why can't you directly keep your entire data in the RAM itself? Instead of keeping into a device which is slow and reading from there to this place, if you directly keep your data in the RAM itself, then you can perform the operations directly on the place where your data is resided. Is my question clear? If this is faster, then keep the data there itself. What is wrong with that? Now tell me what is wrong with that. Yes, RAM is not permanent memory. Okay, good. If the data is erased from the RAM, yes. Only one point, no, RAM is not volatile. When CPU is off, yes, all these things comes into picture. Okay, yes, fine, sir. But okay, forget about the RAM volatile and CPU off, etc. Assume that I have some mechanisms where I'll make sure that your data won't be lost. Don't worry, I'll come to that. So I'll make sure that even though CPU is off and RAM is volatile, I'll make sure that still data is safe. Now tell me, is it a good practice to keep your data in the RAM or hard disk now when you are not worrying about the safe data? I'll make sure that data is also safe. Now, is it not a good practice to keep the data directly in the RAM on the faster device? If the data is safe, conclusion is, condition is data is safe. Yes, definitely yes. Yes, others? Yes, exactly. RAM is expensive. Yes, in the olden days, RAM is expensive. Yes, now the point is, yes, why can't you maintain directly your data in the RAM and this is faster? Yes, it is possible, but very genuine concern is RAM is volatile. That means when you just switch off and switch on, the data in the RAM will be erased, that kind of things. Okay. Now what SAP said, yes, RAM is volatile, everyone know. Okay. Now, keeping your data instead of hard disk in the RAM, your entire database in the RAM is known as in-memory database, IMDB. That means your database in the memory itself. Here itself, I wanted to maintain all the data. I'll come to the volatility. Here itself, I want to maintain all the data. When your data is directly in the faster device, then 80% of your performance is improved, because this is the only area which kills your lot of time. Now that area we are going to overcome just by keeping your data in the memory itself directly. Yes, I know all your questions. It's volatile, etc., etc. Okay. Now, yes, data in is a point clear. In memory database means this is one of the SAP HANA specialty. In memory database means your database in the memory directly, but internally it's not directly. Internally it's not directly. Your data always resides in the hard disk only for the permanent storage, so that your always data stores in the hard disk. But as per the organization demands, data is generally classified as hot data, warm data, and cold data. Hot data means the data which is very frequently required. Warm data the next. Cold data not so frequently required. So what SAP? Who will decide this? The management of the organization. The management of the organization will decide. The management of the organization decide what data they want it frequently, and for which is a complex, and for which calculations make sense, etc. So once the data is segregated as hot data, warm data, cold data, the hot data copy from the hard disk to RAM is loaded for the first time, or every time you restart the server, not your machine. Every time you restart the server, the hot data copy will be loaded into the RAM. That's all. A copy of your data into the RAM. Now, once you get the copy, if at all, if there are any changes, so that you don't need to worry about data loss, because you have the copy only here. If there is any change in the data, in this RAM data, in the memory data, and the HANA, we have some algorithms which will make sure that the data is again send it back. Faster device to slow device. That's what we say something. There is a separate layer called persistent layer. I'll explain in the architecture. persistent layer will make sure that if all there are any changes in the RAM, in the memory, that changes will be returned back. That's all. Next time when you restart the server, latest data will be loaded into the RAM. So that what I am trying to highlight, hard disk is not going to be replaced at any cost. Hard disk is not replaced. Hard disk still remains as it is. But only the hot data, whatever that is frequently required, will be loaded into RAM directly without writing any code. That code, the program, the algorithms are written by SAP itself. So that hot data is loaded, warm data is loaded, cold data. So let us after 1 year the warm data becomes cold data. Again they don't maintain that. Which is warm and which is cold decided by the management. So this is known as in-memory database. In-memory database means your data is directly in the memory. But it doesn't mean that we are not going to have any hard disk and all. Yes, we have to have always hard disk to maintain your data permanently, but the data that is frequently required, for which calculations required, which is complex to analyze, and for which more and more calculations required, calculations are faster in the RAM, so that kind of data will be loaded initially into the RAM. Then whenever there are changes in the RAM data, the persistent layer will guarantee that the changed data will be sent back to the RAM, sorry, hard disk. So that now your solution is done. That means you don't need to worry about volatility, because I'm not completely replacing the hard disk. We're just keeping the data. Now my question is it entirely new technique? No. This is known from the day one onwards. Everyone knows that data in the RAM is faster than hard disk. But why not this is implemented long back? Why we are talking about this one now? Yes, one simple reason. RAMs are expensive in the olden days. That too, RAMs are not available with such a big capacity. If you still remember, I started my career in 2003. That time 4.6B. 4.6B version, I started with 64 MB RAM, I remember. Of course, there may be some people started before me. They may start with only even less than this. 64 MB RAM we used it. Later 128 MB, because that time it's not available at 64 MB means great. 128, then 256, then 512. Now it is GBs. So what I'm trying to highlight, this technique is not entirely a different technique, etc., etc. This is not a very strange or very unique technique. It's a common technique. It's a common sense. It's a common sense. Just keeping the things in the RAM will be faster than hard disk. That why in the olden days they never think of it? Yes, because that time the hardware itself is not innovative. Now the hardware has a lot of innovations. Because of the hardware innovations, hardware becomes cheaper compared to olden days, and even I can store the entire hard disk data in the RAM if required. So RAMs are available even with such a big capacity. That's all what I wanted you to understand. This is not really a unique technique and a great technique. It's a common sense. Keeping the data in the RAM will be faster than hard disk, but worrying about volatility, for the volatility algorithms will make sure that whenever there is something a switch off or this kind of things, the RAM data will be loaded to the hard disk. Every time you restart the server, hard disk to RAM, it's a one-time activity. Then you can do the calculations directly on the RAM. That's what we say. Now you can do your calculations directly on the place your data resides. Now this is the place where my data resides. So I want everyone to understand one point. What is in-memory database? In-memory database means your data is directly in the memory itself. Is that clear? Yes, please. Is this clear? Yeah, so HANA supports in-memory database. Supporting in-memory database, not only just storing the data in the RAM, that mechanism of transferring the data back from RAM to hard disk to RAM should be implemented. Yes, that is done by the persistent layer of HANA. Now this is the first point I want everyone to understand. Next one. But again, I wanted to understand one more point. This is not really a magic kind of thing. This is not something which is unknown to everyone. It is known to everyone only because of lack of availability of the hardware in the olden days, and then also it is a bit expensive, so that we never think of this kind of approach. Now SAP wanted to utilize that hardware innovations. Yes, this is the first one. So directly, yes, your data is in the RAM to your reporting, whatever it is. This is what we say in-memory database. That means you are doing your calculations on the place where your actual data remains, and this is the faster device, so that the calculations are anyway faster. Everything will be faster, just with a simple technique called IMDB, in-memory database. The next one. This is the past approach, this is the present approach. The same thing what we discussed earlier. Your data is in the database. Database means earlier it is a hard disk. From there to your main memory to CPU, cache memory, etc. Now the disk is replaced. I mean, this is still there, but your data is available in the memory itself. Now your job starts from here, from main memory to CPU, cache memory. I repeat, earlier disk to main memory, then from there to CPU cache. Now your data is already there in the main memory, but not all the data. I want everyone to understand that it's not all the data. Again, it can be decided by the organization what exactly the data they want it very frequently to be accessed. That's what we generally classify as hot data, warm data, and cold data. Is it clear? Yes. Next. This is what the fast approach is. This one. This is the current approach. Yes. Another simple example to understand in-memory database. In-memory database. Simple example. Now let us say I asked what is your father contact number. I'm not sure how many people remember. Yes. How many people remember your father contact number? Yes. Your bank account number. Yes. So when I say no, so your bank account number, your debit card number, your mother's so and so number, etc. Most of the times, if you remember, we'll see what happens. If you don't remember, we'll see what happens. Let's say you don't remember your father mobile number. Then what is the process? Go to contacts, open the phone book, go to contacts and search for the name what you stored, your dad or so and so, and then get the number. Same thing with your account number. Account number, generally we have the habit of storing in one message or so and so, that when everyone asks, we'll just send it. Very rarely we remember the account numbers and all. So if you don't remember, the process is this one. If you don't remember the process, this one. This is the process. Your hard disk, your phone book. From there, getting your contact and all, then and open this contact and give it like this. But if you remember, it's already there in your mind. Yes, my number is so and so directly. So that's what, if it is already there in your memory, you can just give the answer immediately. If not in your memory, we have to travel a bit. That's what a simple difference is. If it is in memory, the immediate response. If it's not in memory, we have to spend some time to get it from where it is. Again, if the contacts, so we need to search. When it says start with A, we get all the numbers with A, and B and all the numbers with B. From that B, again, you need to get the exact things. Okay. But question mark is, do you really store all the numbers of your family members and your members of your classmates and then roommates, etc.? No, because your memory is expensive. Your memory is more important than your phone memory. Which memory is expensive, your memory or phone memory? Expensive is more important. Yes, which memory is more important and expensive, your memory or phone memory? Yes, our memory only know. So that is the reason we don't feed everything into our memory. Even though if it is stored in your mind, it is faster. We know that. We know that if you store in our mind, it is faster, but we don't load everything. Same thing happens with in-memory. In-memory database doesn't mean that store everything, only the hot data, which is more important. The same technique we call it as in-memory. That's all. I think now it should be more clear. Yes, the HANA is an application. So when you say what matters, your software matters and hardware also matters, because whatever the points we discussed till now, they're talking about hardware only. Okay, so the hardware and software combination, we call it as appliance. Now we are through with one statement now. We're through with one statement. HANA is an appliance, which is a combination of hardware and software. Known fact is hardware also matters, but how the hardware matters, what exactly, at what level, what is wrong with the traditional approach, we discuss. So that HANA is a database. HANA is an appliance which supports in-memory database. In-memory database means your data directly in the memory. Then I also answered all your questions for volatility, etc. Okay. Yes, shall we go to the next point? Row store and column store, I'll discuss that. That is again technology level. Programming level, I'll show you now. Program level, some changes. Being a programmer, we have few more things to be discussed. Okay, and before that, this one, I wanted to understand one more point, like row wise and columnar store. Okay, I'll come to that. Before that, I wanted to discuss this technical part. Let us say this is our requirement. Like we have the customer invoice table, in which I have customer number, any custom table or standard table, doesn't matter, invoice number, customer number, priority, invoice date, and payment date, and the interest need to be calculated. This is the data which is raw data available in the table. Now my requirement is I want to show this data, but the priority H as high. I wanted to show to the end user H as high, L as low, M as medium. This is my first requirement. Second requirement is I wanted to calculate the due days. How many days are due between these two? This is invoice date, this is payment date, but might be, okay, because there are some terms and payments. As per the terms and payment, if it's paid, it's fine. But payment date is assume that. Otherwise, you can say invoice date and due date based on the terms and conditions. If it's 30 days or 45 days, etc. But actual payment is done here. So I wanted to see at least this difference, payment date and invoice date difference. Now here I wanted to calculate the due days, just the difference. Second calculation. Then third calculation, based on the due days, I want to calculate the interest as well. Interest as per the due date. This is my requirement. In my output, simple requirement. Okay. In my output or in my report, when this is the data, I wanted to achieve these things. This one. Now you tell me what is your actual approach. Now don't worry about HANA and all. If I give this requirement, you tell me what you generally do. What is your first step? What is your second step? What is your third step? Yes, please. What will be your first step? Yeah, what is your first step? I want you to write a program now. Then how will you start your program? If you are ABAPer, I am expecting an answer from everyone. If you are not from ABAPer, I cannot do anything. But as long as you are ABAPer, I am expecting an answer from everyone. First, load the data. From where to load the data? From database table to internal table. Yes. Thank you. Now here. Something like this. Yeah. Yes. First we select the data from database table to internal table. Okay. Next, traditional approach. Next one, we loop the internal table. We loop the internal table. For every record, I need to check the priority. This is my first calculation. Case when priority, when low, I want to show it as a low priority. When M, I want to show it as medium. When H, I want to show it as high. This is my first calculation. Then second calculation is interest and all. Directly, I am collecting the difference between the days. If it is less than 30 days, assume that 3% on the invoice. And if it is between 30 to 45 and it's 5%, else it is 8%. This is the second point. This is what we do. Even though you have 10 years of experience, 15 years of experience, this is what we generally do. Now, if HANA is a backend, now what is the current approach? Now, current approach here is your data is there in the database. You are getting into the application server. Application server means, again, you can compare like a RAM, your memory. Then you are processing here. This is what your current approach. Processing here means you are processing at the internal table. Why to process at the internal table? Because internal table is memory. So doing at the memory level is faster. So that I am doing at the internal table. Nothing wrong with this approach. Nothing wrong. But when your data is already in the memory, then we can start doing your calculations here. Instead of doing the calculations at the database level, here you are getting from data from database into memory, then doing the calculation. No, this is a traditional approach. Now what we can do, let us say my data is already in the memory. So that what you don't need to do is, I don't need to again load it from database to internal table, then do the calculation. It's a two-step process. Load the data from database internal table, then do the calculations. But now the thing is, data is already loaded into the memory. Then directly you do your calculations on the memory. I'll show you the best example. Don't worry. But is this clear? This is what we do. Traditionally, this is what the way you do. As of now. Yes. Now the new approach here is. Okay. Now assume that my data is there in the memory itself. Then what you can avoid, if the data is there in the memory itself, what you can avoid is, you can avoid loading the data from database to internal table, then calculate. We can avoid that loading. We can do the calculation directly. I'll show you how it is. This one. Okay, now this is my application server. I'll say application server or your RAM. This is my database. Now earlier we do this loading, then do the calculations. Now my data is already there here. If you remember, I showed you one diagram, no, past and now diagram. In the past and now diagram, this is loaded from here to here. Then do the calculations. My data is already here. Then I can do the calculations directly on the data instead of loading it. The loading part we can avoid. The loading part only much slower from the hard disk to the RAM, from slow device to faster device. Now read this statement. Maybe it looks a bit different and strange for you, for an ABAPer. Yes. Now my data is directly in the memory. So from the memory I am selecting and processing it. Yeah. Now, because from the memory also I need to fetch the data, right? Without fetching the data, nothing can be done. Okay. So now select customer number. This comma is HANA SQL syntax. Don't worry. Concur, Belnar, net price, IDate, period. These are all the direct fields, straightforward fields. Now observe this. During that selection only, because the data, I am just applying this case statement. Is allowed, along with the select statement is allowed. Now in HANA SQL especially, case priority, when L, then low, when M, then medium, when H, then high. This is what one calculation. But where the calculation is happening, the calculation is happening in the place where the data is. I am not collecting into internal table anywhere. I'll show you the output. I am not collecting this into anywhere. Directly during the selection only, I am selecting this data. Again, I am calculating it. Days between is on HANA function. Again, another case, if the days between is 1 to 30, then 5% of net price. If the days between is 30 to 60, then 8% of the net price. Else it is 10% from your database table. Into table, internal table will come. Yes, assume that into table, internal table is there. Assume that. Into table, I'll just add that also, don't worry. Into table iTab. Now what I got into my iTab directly the calculated data, no? See this. Now what I wanted to understand is I got the calculated data into the internal table directly. I am not getting the data into internal table then calculating. Directly my calculated data in the internal table. My calculations happens on the database layer itself. For me database means RAM. Now what SAP is saying, earlier this is your database and getting into the RAM doing your calculations. Now you do your calculations directly in the database itself. But my database doesn't mean that hard disk. Here my database means my RAM only. My data is already in the memory. Repeat. Now this is my database. Earlier we get it from database into RAM, do your calculations. Now earlier your calculations are this level. Now the calculations are this level only, my database level. Because my database means my memory now. My database means my memory now. So this is known as code push down. You are pushing your calculations here. Come back. You are pushing. This is one level. This is database internal table. Here your calculations are happening. Now my calculations are happening here itself. Because this database is not my hard disk now. This database is my RAM. Database doesn't mean that always hard disk. When it is HANA, you can replace this database word with in memory. Now this is what your calculations are happening here earlier. Now the calculations are happening here. This is what we call it as code push down. We are pushing. The deep priority is a priority field. Don't worry. So we are pushing your code down to one layer. This is what we call it code push down. Yes, this is what code push down. Why it is code push down? My calculations are not happening at the application server level. My calculations are happening at the database layer level because during the selection only I am doing it. But my data is not in the database. This approach is effective only when your data is in memory. If your data is not in memory, this is not effective. I'll give another example. Let us say your select maximum here. Getting select maximum sales order, maximum sales order is doing at the database layer level, or select the sales orders into internal table and then doing it is application level. This is better only if your data is in memory. Otherwise your database will be loaded. If your data is still there in the hard disk, it is loaded. If your database is there in the RAM only, it is faster. So that's what I wanted to ask, understand. Earlier we do the calculations at the application server level. Now we are going to do the calculations at the database server level, because database layer means my in memory. But if the database is really your hard disk, then definitely that is not a good practice. So this is what we call it as code push down, as a new approach. So earlier, yes, here earlier your calculations are here at ABAP level or application server level. This is what, and now your calculations at the database level. SAP HANA database means you can imagine like a in-memory database. So that now your calculations are down here. The technical word is, this is known as code to data. This is data to code. There's another example here. If a traditional database, your data resides here, we get it into this one, and here we do all the logic. Application server level, application layer level. This is database level. If it is HANA, your data plus there only some amount of logic. In the application server, less amount of logic, because everything definitely we cannot do at the database level, right? Everything we cannot do it at the database level. Still few things we have to do at the application server level. So this is what, when you say what is the advantage, the round trips you can avoid it. Again, reading the data from hard disk is more expensive. Expensive means time consuming. But here I am not reading explicitly from the hard disk, this one RAM. Data is already there in the my memory itself. HANA means you can keep in mind that in memory database. When it is in memory, do the calculations there itself. Logic also there itself. See this one layer, here your logic. Now the logic is pushed down to your database layer level. Database layer means my in-memory. When you understand database layer means in-memory, then only it is effective. If your database layer is a normal database layer, again it's overloading the database. That's not a good practice. That's what HANA specified solution help us to move the application logic to HANA. It is called as code push down. The data transfer between application databases is minimized. This is minimized. Number of round trips are reduced. These are the round trips are reduced. This is what code to data. You are coding directly on the data. You can remember like that, code to data. This is a programming level change. Now we are going to write this kind of programs as an ABAPer. That's all. We have few more things. Maybe we'll discuss in the next session. But what I wanted to highlight is the course curriculum. I just wanted to highlight the course details. The actual course details is this one. And generally you might be knowing that when you say any training from various training institutes, each training institute may have their own syllabus. Definitely we can compare like that. Generally we argue with the institute management. This is covered in that institute. This is not covering. Are you going to cover this one, that one, like that? There are a lot of arguments happens between you and the management. This is covered there, you are covering or not, like this. But here we don't have that issue, because HA 400 is SAP course code ABAP for HANA. Even when you want to go for SAP, if SAP want to train you, they'll train you on it. This is the 100% syllabus. No one can do something beyond this. Okay. So this is what the syllabus HA 400. We have that PDF, the latest PDF. We'll share that. And our syllabus is HA 400, ABAP for HANA or ABAP programming for HANA. Even when you want to go for certification, this is the material you need to refer it. But for understanding ABAP on HANA, yes, HANA introduction comes into picture. That is HA 100, HANA introduction. Okay. Then I showed you one SQL statement of HANA SQL. To understand that, one more thing, HA 150, HANA SQL. So we'll start with HANA introduction. Most of the introduction is already done. Then I'll go with HANA HA 150. Then HA 400 is our actual syllabus. But nowadays, more important thing is modeling. Modeling is more important for the BW consultants, but for ABAPers also it's good to know. That is another course code called HA 300, HANA modeling. HANA modeling also at least 50% I'll cover. It's not part of our course, but still, since it's good to know something, I'll cover maximum things from the HA 300 also, HANA modeling. So HANA introduction, HANA SQL, ABAP for HANA, HANA modeling. But this is our actual course. So that you don't need to worry whether this is covered or not. So we are going with this course content. So it's not our specific course, it is universal course. When it's ABAP for HANA, this is what ABAP for HANA. Yes, CDS views for Fury and all comes into picture in the in the ABAP only. CDS views comes into picture, that can be applied anywhere for Fury now, for ABAP, for doesn't matter. It's a view, CDS view, where everywhere it can be accessed. Yes, we'll discuss the CDS views, Fury and all. Session timings, I guess it is 8 to 10, 11, maybe from next week. Anyway, we can have a discussion. But as per my understanding, it is 8 to 11, 3 hours for every weekend with enough breaks. Yeah, that's what. Don't ask me CDS views, AMDPs and all. You just refer the syllabus, whatever you ask. No, AMDP CDS, that's already part of HA 400. In the HA 400, if you want, I can run through the sessions. Yes. So yes, weekends only. This batch is only for weekends, Saturdays and Sundays, and 8 to 11. Maybe your batch will continue from next weekend, regular sessions. Maybe tomorrow for the people who missed today's session. Maybe someone you guys may continue tomorrow. Anyway, the management will communicate with you properly. There's any questions? If you want, I can run through that HA 400 syllabus at least, because you don't need to ask me whether this is covered or not. This is universal. That's what it's yes, syllabus. You can just simply Google it, HA 400, you can get everything. Okay. So course fee, I think I am not the right one to discuss the course fee, but course duration I can say. So so I need 20 hours at least So 4 weekends might be enough. 4 weekends. Yes, 4 weekends. So tomorrow there may not be any new things. I think maybe for new people tomorrow's session will be arranged. Tomorrow may not be new people. Maybe your regular session will be continued from the next weekend only. And one more thing, yes, we have still few more things like HANA architecture, columnar database and all. I'll discuss in the next session, because it might be boring to discuss many things on the same session. So yes, HF 400, yes, even you can simply Google for it. Even otherwise, I have the document. I can just show you that quickly.